Hello again. This time we're going to learn how to trim reads with Trimmomatic. But the first thing I would like you to do is to locate the mito_reads directory, this right here. Now, you should have been able to download it and put it into your home directory, so if you haven't already, make sure you do that before we continue forward. And when you're all set, let's go ahead and cd into that. And then do an ls. All right, so these should look familiar. These are just FASTQ files. And they're compressed, which is why they're .gz, so don't look into this unless you use something like less. And then over here we have a script. So what I'm going to show you is Trimmomatic, but it is a behemoth of a command. There's so many things you can do with it. It's very cumbersome. There are so many arguments you have to give it. So this is actually a prime example where a script could come in really handy, because if we go ahead and make a script so that it does mostly everything for us in this case, then we just can run it again and again without having to worry about typing it all out. So what I've actually done is I've prepared a simple script for you, this trim_script.sh, that you can look into, maybe even run, and modify too. So if you want to use this again for something like an assembly, maybe you can find a way to rejigger it. You might not have this executable when you get it. I'm not sure how it will transfer permissions when you upload it to the server. So if this isn't working, just use a chmod 755 on your trim script, and then that will go ahead and give you back executable permissions, because that's important, because we're going to want to run it like this. Whoops, wrong thing. You would want to run it like this, but I won't get into that just yet. What we should do, though, is go ahead and just nano it, just so we can go inside. The first line, again, is the shebang line. It's just going to tell the Linux, or the server in general, how to run this script. And now what I've prepared here is just a simple redefinition of some of these. So the $ followed by a number, that's actually going to correspond to the argument that you give it. So $1, that's the first argument. $2, that would be the second argument. So when I type out this script and I give it a couple of arguments, those words are going to correspond to these right here. And I'm just redefining them so it's more clear to us what they mean. So I'm expecting the user to do the first argument as the forward set of reads, and the second argument as the reverse set of reads. So the ones that we just saw in that folder, basically. Okay, now we have this. This is actually one command, believe it or not. What I've done is I've actually broken up this command into several lines because it's easier to see that way. And to do this, I've used this backslash right here. What the backslash will do is it will just tell the server that the command you're running is broken up into several lines. So you can delimit these lines with this backslash, and it will just combine them all in the end. But keep in mind that you can't have a space after this. You should have a new line after your backslash, because otherwise it's going to treat it as the next line and it gets confused. So make sure you just have a new line, a new line directly after your backslash to have it all nice and pretty like this. Anyway, let's take a look at this. This should be familiar right here, this no-hop command. This is because maybe the Trimmomatic script will take a very long time. I mean, I don't predict it to take forever. And in fact, the sample reads that I've given you, the mitochondrial reads, are very few. So this should run pretty fast. The next part is the Trimmomatic script command itself. So this is a JavaScript or program, and you can run it just like any other command. Okay, the next part, PE. What that stands for is paired end. And now the majority of what we're going to be doing is with paired end data, but if you want for some reason to use singled end, you can use SE instead. It is case sensitive, so make sure this is capitalized. All right, the next one is threads. So you can define the number of threads you would want to work on this if you want to make it go faster. Now this is going to depend on where you're working. Like for instance, if you're on your laptop and you only have a couple of cores, 8 threads might not make sense. So our servers have a lot of cores, so it makes sense to have multiple threads, but don't get greedy. 8 threads is probably enough for what you want to do here. You can also just run it on a single thread if you want. It doesn't matter too much. I just want to speed through this, basically. All right, now the next part, this is where we begin to use these variables, and this is where it's starting to come in handy. So this is again corresponding to our first argument, and this is corresponding to our second argument. Now the first two arguments that Trimmomatic will take is the forward set of reads and the reverse set of reads. So here, right off the bat, I'm just saying make those the first two arguments of Trimmomatic. And then I go ahead and just do a new line here so that it's just not a giant line right here. So here's the second part of it. Now what Trimmomatic needs to take are the outputs of the paired and unpaired reads after trimming. Now these are going to be things that are created when this is done. And what's going on here is that based on your settings and filters, you might have to throw a read out because maybe it's like really low quality or it's super small after you've trimmed it. In those cases, you throw out that read, but now it's mate pair. Like for instance, if I throw out a forward read, then its reverse read might still exist because maybe it's still fantastic quality. When that happens, it's orphaned, and then it goes into that unpaired file. So that means my orphaned forward reads, the ones where the reverse reads have been thrown out, but the corresponding forward read is perfectly fine, are going to be located in here. And then the ones that still have their mate pair, so the forward reads that still have their reverse reads after trimming, instead go into this one right here. Now I've done something kind of clever here. What I've done is that it needs to take some new file names to create. And what I've actually done is I've just taken the name of the forward argument and I've just prepended this right here. So that means it's going to create this paired underscore file, and then the rest of the name is going to be whatever you have as an argument. And then again, this is going to be an unpaired underscore followed by whatever the name of the forward reads is. So this is just a lazy way, I guess, of creating the names of these on the fly without having to type it all out again. And that's something kind of cool you can do with this, is you can concatenate to your variable. So this is a variable again, but it will know that if you give it something right next to it, it can concatenate it as one single argument. So I guess keep this in mind. This could be a useful trick for other things. But that's all we're doing right here, is we're just creating some new names with some old names. Anyway, so that's what you had to do for these two. And you're going to have to do pretty much the same thing for the other set of two. So this is reverse reads in general. So again, this would be the reverse reads where the corresponding forward read still survived after trimming and filtering. And these would be the reads in which the forward read didn't exist after trimming and filtering. So then you only have the orphaned reverse reads in here. So you're just going to have it all typed out like this. All right, and then we go on to the next line. And this is a bit of a long line. It's one whole thing. This first part, this is saying that what I'm going to give it is the pathway to a set of adapter reads. Now, when you use something like Illumina, you're going to get a set of adapters that might still be stuck onto your reads. And we can trim for them. We can look for them and we can trim for them so that they're no longer on those reads. So it's going to shorten those reads based on the size of that adapter. And this is just the pathway to it. This is the default pathway. So if you've installed Trimmomatic somewhere, this should exist as the default pathway. So if you give it this, it should still point to it if you have this installed on a different server. And if you want, you can go ahead and give it your own set of custom adapters if you like, because all an adapter file is just a FASTA file containing the sequences that you'd like to get rid of. That's it. So these are pretty small sequences. You can go ahead and check them out if you'd like. This next part is another default. What this is, it's the minimum quality, average quality that a read needs to have, I believe. Otherwise, it gets thrown out. So I kind of just leave it as the default here. And then here we go, another new line. And this is a sliding window. This is another kind of metric where it's just going to look along. It's a 4 base pair window. It starts at the beginning. It just slides along the read. And then it's going to check. So whenever the average quality of those 4 reads is 15 or less, then it's going to just go ahead and trim that off and just keep sliding it on until it gets to a better part of that read. I think it does this before it does the average quality check. So this is a way to save your read. If it turns out there are just some crappy things at the beginning or the end that you need to get rid of, then this sliding window can take care of that for you. But then we have another issue. What if it gets rid of almost everything? Do we still want to have that stubby little read remaining? Probably not. So another command you can use, another setting you can have for this is min length. It's the minimum length that a read has to have or else it's thrown out. So after trimming, I might be left with a read that's only 10 base pairs long. That's not terribly useful. So what this would do is it would get rid of it because it has to be, I believe, at least 36 base pairs long. Otherwise, it gets thrown out. I think this is the default. You can mess with this as much as you'd like. Maybe you'd like to have it higher or for some reason lower, but there you go. And then finally, right here, we have an ampersand. And that's just to say run it in the background, because maybe you have like a bunch of assemblies you have to do. And the first step you would want to do is to just run Trimmomatic on all these things. So there you go. You could just have it running. So then what this would do is it would run it in the background. It would redirect the standard out to no-hop.out. And it just runs it no matter what. So you could close your laptop or do something else. And it's still running for you. So now we can actually give this a try. I'm going to just Control X to get out of here, to exit. I haven't made any modifications, so it didn't ask me to save it. And I'm going to do another S. So we can use this script. Remember that if you're in the same directory as your script, you have to do the dot / and again the dot corresponds to your current working directory. So it's just saying the script I want to run is in my current directory. And again, it's just to avoid ambiguities, because maybe you had something similar as in a path variable somewhere. But anyway, so I'm going to run this script, and I have to give it 2 arguments. I'm going to autocomplete the heck out of it. So I'm going to specify the forward set of mitochondrial reads and the reverse set of mitochondrial reads as the second argument. And again, I'm just using autocomplete. I can't type this fast. I wish. So this is the first argument. This would be the number one, the $1 in that script I just showed you. And then the second argument will be the $2. And now we can just go ahead and hit enter a couple times. This shouldn't take too long. I mean, this is a pretty small data set. But we can see that if we run do jobs, we can, oh, it's already done, I believe. Yeah, that was super fast. So actually, we're all set. You can even do a more here. So this is the no-hop.out. We can go ahead and look inside of it to see what just happened. This is the standard output of Trimmomatic, so like the report of what it did. This is the number of reads that are surviving. So this is like a super small data set. We've got like barely any reads in here. But you can just see for tutorial purposes what it does. I think these were already pre-selected to be really awesome reads, which is why none of them got tossed out. Because as you can see here, all of them survived. So actually, we didn't need to run Trimmomatic on this. But when you get your real data sets, you will need to. So you're going to see something different. You're going to see that probably not a lot of them are going to survive, especially the reverse reads. So don't be alarmed when that happens. That's to be expected. But the reads you get are like super high quality ones afterwards, so it's worth it. You can also do an ls to see what else is in here. So these are the files I was talking about, the paired and the unpaired files. So for the next part, when we're going to do assemblies, we're going to be mostly concerned with the paired ones, because these are like the better quality sets of reads. And we can afford to toss these away because we'll usually have so many reads that you'll have enough just in these paired ones. So that's what we're going to cover next time, is how to assemble using these trimmed reads. Hold on to the originals too, because maybe you want this as a backup. So just keep in mind, don't delete this unless you really need space. But you can probably delete these unpaired ones. But anyway, until next time.